Let's look at two exam questions as a recap of the first year integration content. So what we've got in this first question, we've got a cubic, which is y equals x cubed minus 10x squared plus 28x. We can see that because it doesn't have a constant at the end, then if we took x out as a factor, we'd have a root where x equals 0. Obviously we've got a maximum point, we've got a minimum point, and we've got a positive cubic shape. The question basically boils down to finding the area of this region here. Okay, we've got a point P, which is at our maximum point, and then there's a tangent, which is a tangent at the stationary point, don't forget, would be a horizontal line. So this horizontal line is a tangent from that stationary point, and we want to find this area in here, so between the horizontal tangents, between the y-axis, and between the curve. So obviously we're going to have to integrate to find an area, but we're also going to have to differentiate to find the stationary point. First thing I'm thinking is let's find the coordinates for the stationary point. So dy by dx would equal 3x squared minus 20x plus 28. At the stationary point, set it equal to 0. No common factors, so we can't divide by anything. See if we can factorise it. If in doubt, use your graphical calculator or the quadratic formula, but with 3x and x, both negatives, because it's a positive 28, and sum is a negative, and then factors at 28. 2 and 14, because we can put 14 there, and 2 there, that would give us minus 6, minus 14, minus 20. Okay, so we know that stationary point would be x equals 2 and x equals 14 over 3. 14 over 3 is bigger than 2, so 14 over 3 would be this one over here. We don't really care about that one, so we do care about this one. So at that point, we know that so far the x coordinate is 2. So let's quickly get the y coordinate, so we can figure out this line here, because that's the horizontal line is a y equals line, isn't it? So if x equals 2, y would equal 2 cubed. 10 times 2 squared plus 28 times 2. Use your calculator if you need to. That's going to give us a y value of 24. Okay, so we've got the coordinate 224. In other words, we know that looking at this rectangle here, the base is 2 and the height is 24. So the overall area for that shape there is going to be 48 units squared. Okay, and if you look at what we're being asked to find, we're being asked to find this region up here, which is actually the region above the curve. Okay, so if I integrate the curve between 0 and 2, that's going to give me this shape here, isn't it? And the bit I want above, I can just subtract this area from the 48 and it'll give me the region above. So to find this green area, we can integrate the cubic between the limits 0 and 2. And obviously integration is just the reverse differentiation, isn't it? So we increase the power, divide by the new power. It's the opposite and the opposite order, isn't it? So x to the 4 over 4 minus 10. Always think about your power first when you're integrating, so that'll be x cubed over 3 plus 28. Add 1 to the power x squared over 2. Sometimes we need the constants, but when we're integrating with limits, we don't need to worry about the constants, because the constant would cancel when we subtract. So we sub in our limits 2 and 0. The way you want to set this out to get your method marks, use a big open brackets. When you substitute 0 into this, because everything's just a power of x, that would just be 0. In some of the questions we're going to move on to, subbing 0 into exponentials into trig functions, you don't always automatically get 0 here, so just be careful with what's going to come next. But obviously we substitute 2 in, 2 to the power 4 over 4 minus 10. You're only cubing the 2, don't cube the 10. Plus 28. 2 squared over 4. Use your calculator and tally this up. If I check the answers on the sheet, apparently that's going to give us 100 over 3. Okay, so I know that that green area here is 100 over 3 units squared. And the region that we want, which is this bit up here, is going to equal the total rectangle minus the bit underneath the curve. So R would equal 48 minus 100 over 3, which will give us 44 over 3 units squared. Second example is about the other application of integration. So we looked at integration to find an area, but now we can think about integration as being the reverse process of differentiation. So we've got a curve defined for x is greater than 0. You probably want to highlight that, like whenever they give you the domain in the question, you're probably going to do a load of work and then forget about that at the end, so it could be important that. The gradient is given by dy by dx equals x to the 3 over 2 minus 2x, and the first part of the question says show there is a single value for x for which there is a stationary point. So obviously just interpreting this, we're thinking about when dy by dx would be equal to 0 and there's a single value, so we're only expecting to get one solution here. So let's just set dy by dx to be equal to 0, so we've got 0 is equal to x to the 3 over 2 minus 2x. And we just need to rearrange this to find out what the solution is for x. You might be tempted, no, a lot of people will do this, they'll divide by x. And technically you will get away with it for this question because we know x is greater than 0. But the better way of doing this, the more consistent mathematically, is actually not, you don't really want to divide by a variable if you can help it. Take out a factor of x. And if you take an x to the 1 out of x to the 3 over 2, you'd be left with x to the half. Taking x out of this, you get minus 2. And then we've got this thing that we love in maths, two things times together, and the answer is 0, so we can just think about them separately. X equals 0, x to the half equals 2. X to the half is the square root of x, isn't it? So the square root of x is equal to 2 is the same as saying x is equal to 4. If we just square both sides, don't need plus or minus, we're squaring, we're not square rooting. So if you square both sides, you just get 4. Why have we got two solutions? Well, don't forget x is greater than 0, so I would state as x is greater than 0. You still want to show the working out here and give a reason why you're not going to use that solution. Okay, so our single value of x, we don't need the y value, we've just got our x value, and therefore, one stationary point. Part B then says find the second derivative, d2y by dx squared, and hence show the curve has a minimum point. So don't forget, we know that the stationary point is when x is equal to 4. And we're aiming to show that this has got a minimum point at x equals 4. Don't forget, when we're asked specifically about the minimum, that's telling us that the second derivative is greater than 0. Okay. So, second derivative, d2y by dx squared, times by the power, take 1 off the power, minus 2x, become minus 2, if x equals 4, d2y by dx squared. Square root of 4 is 2, so times by 2 divided by 2, we're left with 3 minus 2, which is 1. Now just back up what you're sort of going to argue here. So we clearly state that 1 is greater than 0, and finish off by saying therefore minimum point. Final part of this question is a bit of a more awkward one to interpret actually, so just have a little read of it first and we'll try and break down what it's telling us. It says the line with the equation y equals 2 is a tangent to the curve, and it says find the equation of the curve. Let's focus on what the final part says. So it's obviously find the equation of the curve. That's asking, well, what does y equal as a function of x? So I know that, well, if I've got dy by dx equals, and I need to figure out what y equals, I'm clearly going to be integrating this function here, aren't I? But when I do integrate this, I'll need a plus c, and I've got to figure out what the constant is. Usually it'll just give you a coordinate on the curve, but it's maybe not quite as straightforward for this one, because it's not saying here's a coordinate, find the equation, so you just integrate and sub the coordinate in to find your plus c. It's given as a line y equals 2, and whenever we get something a little bit more abstract, I always like to go back to like visualising what's going on here. So a line y equals 2 would be a horizontal line, wouldn't it? And it's saying a horizontal line is a tangent to the curve. Now we've got to realise that we know that there's a minimum point on this curve. So whatever, I don't even care what the function actually looks like, but I'm just trying to visualise the fact that this function has a minimum point. And if a horizontal line was a tangent, that would have to happen at the stationary point, wouldn't it? Because if it was any other point on the curve, if I drew a tangent here, it would be a positive gradient. If I drew a tangent here, it would be a positive gradient. You know, if the curve was down here, it would be a negative gradient. So that I've got to piece apart this sentence here, and the fact that I've got a horizontal line, which is a tangent, tells me that that must occur at the stationary point. So I do know a point, I do know a coordinate, don't I? Like that coordinate for that stationary point there, we had earlier, the x value was 4, wasn't it? So we also know that the y value is 2. So this is the point on the curve that's going to allow us to find r plus c. Okay, so now we can integrate both sides with respect to x. Oops. Well, obviously if we integrate dy by dx, we just go back to y equals, don't we? If we integrate this side, add 1 to the power, just be careful with your fractions, so it'd be x to the power 5 over 2. Divide by the new power, like I never write divide by 5 over 2, just when you divide by a fraction, multiply by the reciprocal. Okay, minus 2, add 1 to the power, so that'd be x squared, divide by the new power, plus c. Please don't forget this. This is like so important on this path. Okay, so let's just tidy it up a little bit. You've got y equals 2/5 x to the 5 over 2 minus x squared plus c, and we know that the coordinate we can use is 4, 2, so when x equals 4, y equals 2. If we substitute this in, you can use your calculator for this, but you might be able to do it without the calculator if you understand what this power means. Like, if the power's a half, it's the square root of 4, and then that's all being raised to the power 5, and then minus 4 squared plus 2. So what we've got here is the square root of 4, which is 2, and then 2 to the power 5, so it'll be 2, 4, 8, 16, 32. So we've got 2 equals 2/5. 32 minus 16 plus, what have I done there? Why have I put plus 2? Sorry, that should be plus c, shouldn't it? Apologies guys. So the whole point of doing this is trying to find out what the constant is. Okay, so now we can just rearrange to figure out our constant. And we end up with c equals 26 over 5. So we should actually answer the question. It says find the equations of the curve. So the answer would be therefore y equals 2/5 x to the power over 2 minus x squared plus 26 over 5. Okay. So exercise 1 is a bit of a recap on the first year integration. It is important that you try these questions because there's a lot of content on integration that we're about to cover, like a lot of new content, so you need to sort of consolidate your knowledge before we move on. So try and work through exercise 1 please guys next. Thank you.